Okay, welcome back. We have been talking about the massive stars and their journey through the stellar evolution process to get to their ultimate end state, which is a supernova. I want to talk a little bit more about supernova and supernova remnants in our last video of the day. So, supernova are extraordinarily important in the galaxy. Um, the density and the temperature and the neutron count in the ejecta is very high. This is a lot to say. Let's unpack this. The density and temperatures are very high. That makes sense. The neutron count is very high. Why is this important? It's important because as this infalling material slams into the outgoing material, nuclear fusion can happen. And there's so much energy available, and there's so many neutrons around, and there's so high temperature, and things are moving so fast in opposite directions that you can get reactions that normally you couldn't get happening there. And in fact, elements more massive than iron can be synthesized and blown off into space for the next generation of stars to incorporate them. So for instance, let's go back to our periodic table. Here it is. So you might remember, iron is the most massive element that can be synthesized in the centers of stars. Nothing more than iron can be made. So the question you might ask, and it's a good one, why is it that we have these heavier elements on the Earth? Almost all of the naturally occurring ones, meaning non-radioactive ones, we do find on the Earth. We have xenon and indium and calcium, cadmium and silver and gold and platinum. All of these elements, where do they come from? They can't be synthesized in the centers of normal stars. They are typically, all of these elements past iron are synthesized during supernovae, during these very energetic events. The only reason why there's gold and silver and mercury on the Earth is because at the beginning of the universe, there were these massive stars. They did go through these supernova events, and these elements were synthesized in them and blown off into interstellar space, and the next generation of stars that formed had more of these elements in it than the first generation did, which had zero. And the next generation after that had more of these elements, and the next generation of that had more of these elements. And you fast forward something like 8-7 billion years, and the sun is formed with a fair number of these heavy elements. Now, the sun is still almost all hydrogen and helium. We'll get to that later in the semester. The universe began almost entirely hydrogen and helium, but it has been slowly building up these heavier elements since. And at least in the case of these heavy elements beyond iron, almost all of them happen in supernovae. So supernovae are extremely important for us being here. We wouldn't be here if things like nickel and copper and zinc and iron hadn't been synthesized in supernovae in these massive stars. Things like the Earth wouldn't form. Things like carbon are here because these things got blown out into interstellar space. Okay. Let's go back to PowerPoint slide. Here we go. So let's take a look at some supernova remnants. Again, these things are very bright. They can exist for a very long time. They're going to look a lot like planetary nebulae, but these things are extraordinarily larger and more energetic and less frequent. They're very bright in things like X-rays and in radios, and they can persist for thousands of years. This is a supernova remnant called Cassiopeia A, which is a very large supernova remnant. There's a cool supernova animation video I'll try to remember to post it to the page where I'm posting these videos this time too. And you can take a look at that. Here's some more pretty pictures of supernova remnants that have gone off. Again, over the past several thousand years, these things are still glowing brightly in various wavelengths. This one always gets me. Look at that. Amazing. Now, interestingly, there has not been a supernova that's gone off in the Milky Way in our galaxy since the 1600s. Tycho Brahe, remember him from observing Mars fame, made observations of the last supernova that went off in the Milky Way galaxy. And that's unusual. Typically, a supernova will go off in a galaxy about once every 100 years. And it's been more like 400 years in the Milky Way since a supernova has gone off. So perhaps a supernova is due to go off soon. If you've been following the news with Betelgeuse, it is a star that will go supernova someday. It is very close to us. It's supernova. If it did go supernova, it would be a spectacular event. I'll say more about, but supernovas, Betelgeuse itself is doing some interesting things right now. It has dimmed quite a bit over the past several months, and nobody's really sure why. So it could go supernova today, it could go supernova tomorrow, it could go supernova 10,000 years from now. We don't really know, but it's any time now Betelgeuse could go. And if it did, it would be as bright as the full moon in the sky. You would go out on a clear night in Betelgeuse, there would be shadows on the ground cast by Betelgeuse in the sky. It would be that bright and that spectacular. It wouldn't be as big as the full moon. It would still look like a single point of light. It would just be extraordinarily bright for several months as it slowly descended in brightness. So look forward to that. I hope it happens in our lifetime. It probably won't, but it could. Now, the closest supernova that has gone off, none have gone off in the Milky Way galaxy, but a supernova did go off in a satellite galaxy to the Milky Way. I believe it was in the Large Magellanic Cloud, yeah. And that was supernova 1987A, which was, believe it or not, the first supernova that was discovered in the year 1987. We're not all that creative at naming things as astronomers. Anyway, supernova 1987A, I remember this. I was probably 13 years old when this happened. So in 7th grade or something. I wasn't an astronomer at the time, but I did hear about it. It was a big event. It was visible with the naked eye. Now, the Large Magellanic Cloud is unfortunately a southern constellation. It's not visible from the northern hemisphere in most US states, but it was visible to the naked eye. And so that was exciting. And it's the first, and I think still only supernova that's ever been detected where the progenitor was known. What does that mean? The progenitor is the star that was there before the thing went supernova. We had observed that star, we had made measurements of the star, we had cataloged it. It was a B3 supergiant. So B, remember, these are some of the hottest stars, and 1 is a supergiant, all the way at the top, way above the main sequence, which is good. If it had been a dwarf star, a luminosity class 5 star, let's say a K star or something, that would have broken all our models of stellar evolution and we would have had to go back to the beginning. This confirms these stars, we should go supernova, these supergiant stars. Anyway, here it is. Here is the star before it went supernova, right there. There is the star bang after it went supernova. This says 1978, that's wrong. It should be 1987. In any event, look at that huge difference in brightness. Again, this is what a factor of 100 billion in brightness looks like. It's extraordinarily bright. So this is still the best studied supernova that we've ever got. This is what it looks like today. Bizarrely, and today by I mean in the past several years, this is what it looks like. You can actually take an image of this object and see what it looks like. The cool thing is it's got all these weird rings, and these rings aren't even centered on the same thing. But if you remember back to our very massive star that we looked at, Eta Carina, the 100 solar mass star, and remember that it had 2 lobes, one pointing in the rearward direction and one pointing in the forward direction. We think that this star must have done something similar. And the shock wave after the supernova went off, you've got a disk of material which is heated up, but these 2 outer rings are probably the shock wave passing through these 2 lobes of material that were previously ejected by the star that looked very similar to what we saw from Eta Carina. Here is a explanation of the rings where you can sort of see this outflow of gas, and as the shock wave passes through, it gets lit up in these rings as it goes out. So that's fun. The inner ring has changed quite a bit over the years. This is from 1994 to 2009. This is already over a decade old. But you can see various notches and nodules and things as this thing progressed. Supernova 1987A was amazing for a lot of reasons. One of the other reasons that it was amazing was it is, I believe, still the only astronomical event or object that we know of that we have been able to detect neutrinos from other than the sun. And so when Supernova 1987A went off, remember there are these neutrino detectors that are sitting there just watching, waiting for neutrinos to go by. They went back and checked, and sure enough, the Super Kamiokande site, that giant tank of water, saw 4 neutrinos from Supernova 1987A. Remember where these neutrinos come from? In the photodisintegration process, when protons and neutrons are combined, or protons and electrons are combining to make neutrons, a neutrino has to be made in that process. And it has to be made, there has to be enormous numbers of these neutrinos that are made instantaneously. And those neutrinos, again, largely just propagate outwards. Now, the material is much more dense. Some of them will get absorbed by the surrounding material, but most of them will get away. And there are so many of them that even one small little detector on planet Earth, thousands and thousands of light years away, was able to detect 4 of these neutrinos. It was a pretty cool confirmation of what we think was going on in that supernova and observational evidence to back it up. All right, so that is the end of our discussion about high mass stars. We will come back next week and talk about the deaths of stars and the remnants that are left behind after these stars die. So have a good weekend, and you can look forward to that. See you next week.